morning, everybody. Can you hear me okay? All right, excellent. My name's Jim Hassman. I am the Group Vice President of Industrial Sales at C3, and I'll be doing the first part of the presentation today, and appreciate all of you coming. This is a great opportunity to allow us to explain what we do and how we help companies. And one of our customers is here today. Julian from NG will be talking about their experience with C3 and what they're doing as a business using our platform on AWS. So again, thank you all for coming today. And I want to get to know who my audience is before we get started, because I can kind of tailor this depending on who's here. How many of you are technical or from IT? Raise your hand. Okay, may not need to ask the other questions. Any analysts or consultants here today? A couple? Okay, how many from the business side? All right, okay, so we can do this. Any data scientists? All right. Okay, so here's what we're going to do. We're going to talk about this topic, accelerating enterprise AI application development. So hopefully you're all in the right session. What we're talking about here is an ability to solve business problems that have tremendous economic benefit very, very quickly. There are a lot of ways you can do this. Some of them are slower than others. And so I'll help explain kind of how we help. Some of you have heard of C3. Maybe I'll do a show of hands on that one. How many of you have heard of C3 before? Okay, not very many. Perfect. So I know where I need to go. We are a software company. We provide a platform to companies looking to transform and to accelerate the rate at which new classes of problems can be solved and new forms of economic benefit can be driven to the bottom line. Our goal is to help these companies re-engineer and re-architect the way they approach application development. Many of our customers have outsourced themselves to the point where they actually don't have a lot of internal technical development skills anymore. Many of them are going through large transformation processes. Many of them have very siloed business units that allow their business units to kind of do whatever they want. Go solve the problem however you want. What happens is you end up re-solving the problem over and over and over again in each business unit. So we're trying to help companies adopt new techniques, new technologies at a much faster rate, and actually develop their own internal development skill sets. C3 is not doing all of the development for these companies. We live at these intersections that you see here on the screen: elastic scale cloud computing, big data, the Internet of Things, AI and machine learning is a big part of what we do. And all of this kind of points to this focus area of digital transformation. The types of problems that we're helping companies solve are typically in the area of predictive maintenance, supply chain optimization, inventory optimization, quality, demand forecasting. We're in a variety of sectors: banking, manufacturing, aerospace, financial services, healthcare, utilities, oil and gas. And we are the leading provider of big data, IoT, and AI applications. And we'll talk about this. Any of you may have used the word, hey, we live in this constant state of doing POCs. I don't know if that resonates with anybody, but we try and we try and we try and we try and we try. Very few of these things go to production. What we're talking about here are applications that go to production at enterprise scale, and it happens very, very rapidly. We are a platform as a service. We are a data integration platform. We are a rapid application development platform. We are massively scalable distributed processing platform. And we have been tried, tested, and I would use the word hardened. And that is very difficult to achieve if you're doing it only within the walls of your own company. We're doing it, at many, many large customers, which kind of forces things like security, auto-scaling, encryption, and all of these things that you may or may not take for granted. We've been at this about 9 years. We've invested about $400 million in the engineering effort to date on this platform. Our core IP of what we do is about 1 million lines of Java code to date. This platform is very open, it's very extensible, and it has solved many, many different problems that we could have never foreseen. We're able to leverage services from AWS, open source services, what have you. So I'm going to walk through this a little bit since most of you are technical, and I'll keep it in a frame or a state where hopefully everybody can grasp the concept here. Over on the left-hand side of this picture, you see a bunch of data sources that are depicted, and I like to think that we integrate 3 kinds of data. We integrate data from existing IT and OT systems. You have hundreds, if not thousands, of these things, depending on what your company does, how you've acquired your way into certain markets, and you have a whole bunch of systems. You may even have a lot of data lakes. The second kind of data is data coming at high volumes from sensors. And when we started this company, we weren't using the word IoT. We just called them sensor networks or devices. But you're getting high telemetry from these devices, sometimes at rates that you can't actually support. The third kind of data is data that's not yours. It's external data, third-party data like weather APIs, terrain, market indices, commodity prices. These are another class of data that you can bring in. So our customers that we support are really looking at a massive data integration problem, but they're solving it from the business side. What is the business problem we're trying to solve, and what data sources do we need to bring in to this platform? One of our customers is bringing in data from 2,000 IT systems. 2,000. Some of these were systems they bought and implemented through SIs. Others came from companies that they acquired. And what they wanted to do was have one single source of the truth so that they could solve some very complex AI problems on the other end. One of the other components of this is that we architected, if I go back one slide, we architected this platform to provide you all the necessary services that you need to develop applications very quickly. So I'll just go from the bottom up, and then I'll move through this pretty quickly. All of the platform services that you would need, encryption, auto-scaling, API management, those are all there. I'm kind of rushing through this a little bit. Data virtualization. Not all of your data sources need to be replicated in the C3 platform. You can actually virtualize and call external data sources where the data are good. Continuous data processing. Any of you that lived through the era of kind of Hadoop as the main data source for your company know how difficult it is to keep the analytics current. You basically put all the data in a bunch of pots and reboil all the pots all the time to make sure that the analytics are current. With the C3 platform, we're actually analyzing each data component as it comes in and only processing the analytics for those as they arrive, but always when they arrive. So you're kind of managing this cost efficiency of using cloud scale computing. Moving up to the top, AI and machine learning. There are a bunch of ways to do this. There are a lot of libraries out there. We just incorporated all of them. And as new ones come out, we incorporate those. So when a data scientist uses our platform, they're not having to basically assemble these libraries or frameworks. They're all there for them to use right out of the box. Moving over to the right, the end state is typically an application. Most companies are not using our platform to just dump data in. Most of them have business purposes identified. They may start off with one or two very critical ones around their supply chain, their manufacturing processes, predictive maintenance, what have you, but will quickly scale out to many applications. In some cases, some of our customers have identified hundreds of use cases for development on this platform. And fourth, across the top, is a layer of tools that make it easier for developers to do development. We support everything from, if you want to write code, you can write code, to complete GUI-based. This all sits on top of AWS. And the secret sauce around what C3 provides is the orange box that you see going around this platform, the C3 type system. I wish we had hours to spend on this topic because it's pretty fascinating, but our approach to this was never to hard code anything. So any underlying service that needed to be taken advantage of, we would actually integrate into the platform through this concept of a type system. It's basically an abstraction layer that sits between your application and the underlying services or technologies needed to support that. The type system serves a lot of purposes. One of them is for all of the AWS services that are needed to make this kind of a platform operate and scale and process data and analytics and AI, all of those necessary services from AWS are pre-integrated. So when a customer purchases the C3 platform to do application development, they start building applications on day one. They are not spending time putting all of the AWS Legos into place. That's already done for them. This platform deploys into your AWS cloud environment, wrapped with your security. The data you put into it are yours. The analytics you build on this platform are yours. The applications you build on this platform are yours. And so we've really provided something that allows customers and companies to solve business problems rather than putting Legos together, which, as you all know, takes some time to do. You can see a depiction of AWS IoT, Amazon S3, RDS, DynamoDB, Redshift, EMR, EC2, Elastic Cache, deep learning, file system. These are examples of some of the services, it's not all of them. So what does this look like simplified? If you think about the people who interact with the data, with the analytics and the applications, it's typically a data integration engineer, an application developer, a data scientist, a business analyst, or even other systems or machines. Those are kind of the 5 classes of users of our platform. None of them are writing direct SQL code to get data out of Postgres, for example. None of them are writing CQL code. They're writing very simple syntax that interacts with this type system, and the type system manages what to bring back for the user. If the underlying services need to change over time, and as you guys follow this market, you're all smarter than I am. You know how fast the rate of change is happening with the underlying services, or Legos as we call them, is. These providers in the market are continuing to provide new services. I'm sure Amazon is going to make a slew of announcements this week on new services. This happens very, very fast. And if you're trying to keep up with that as a core offering of what you do as a business, that's a big investment. We built an architecture that makes it very easy to have these things plugged in for you already. And so as they're there and they're needed, you can take advantage of them. And that's what this type system does. It basically abstracts away that underlying layer from the developer. One of the other cool things about the type system is that all data are types. And all types are RESTful APIs out of the box. All analytics are types. All machine learning models or deep learning models are types. Everything's an API. Everything is reusable. So if one business unit goes and solves a problem and they integrate 8 data sources, the other business unit who comes in to solve problem number 2 can add to that and take advantage of what's already there and not have to redo that work. So the reuse is quite high. So for an AWS perspective, all of these services are already there for you, as I've mentioned. I'm going to quickly go through that architecture slide, because I know that's what a lot of you came to see. At the heart of the C3 platform is this type system. And it is the language and the thing that binds all of those users together. Types are metadata, they're processes, they're referential integrity of types is guaranteed. And so as you look at what used to be called master data management, you're now able to build new classes of data models very, very quickly, and you can afford to get it wrong. Quite often we see that. Somebody's idea one day gets reshaped with the next problem they solve, and that's completely okay. This architecture supports that. The way we bring data in, we bring it in through, if you're familiar with what a canonical data model is, there's a type called canonical, and it makes it very easy for us to go to these systems that I described in the beginning and integrate data in. Actually, when I started at the company 8 years ago, this was what I was working on. And you know, it's evolved greatly since then. But you know, we've got companies who have acquired tens to hundreds of other companies, all who have their own ERP systems, they have their own Pi historian systems. All the data that are used to run those components of their business were set up differently by somebody, and they need it to be common. So this canonical data integration process allows us to very rapidly bring those data in from these disparate systems and turn it into something that's common very, very fast. The data become normalized. We line everything up on time. This is the world's greatest time series platform. Everything is controlled down to the data or type level. So default access is no, and companies like that. It's massively scalable and horizontally scalable. It's open and user extensible, and we support structured, all the data types you see there on that last bullet point. What are the types of data integrations? These are just a sampling. I don't even know how many different types of disparate data sources we have connected to. Some of them we've never seen before. That's never been a blocker for us. Some of them were developed by the companies themselves 10, 15, 20 years ago. The classes of data, relational, non-relational, key value stores, HDFS, graph. Graph is actually a big deal. When you get into solving some of these problems, it's not, having all your data in a file system isn't sufficient, because you need to be able to understand very complex relationships in order to solve some of the AI problems. Multidimensional data, the data are stored as metadata. Where they are persisted as they come in is declared. So if I want data to come in and be persisted in Cassandra or Dynamo or Postgres, I just declare it on the type. The platform handles the persistence for me. The platform services, I would say the big piece of this is actually managing the scaling, the security, when the analytics fire, why they fire, what they're fired for, and really managing the elasticity of that cloud infrastructure that you're using, both for a performance perspective and an SLA, but also a cost component, right? You all know this can get very expensive very, very quickly, and so we've tried to optimize for both performance and cost. We can virtualize external data. We can bring data in through batch, streaming, iterative, and continuously. For the data scientists in the room, I think I saw about 10 or 12 hands. We support, Jupyter Notebook with IPython. We support RStudio. All of the libraries that you like to use and leverage are already there, and they exist as types. If you've built your own libraries, those can be integrated. As new libraries or frameworks come out, we quickly integrate those so that you can go to one place. And I would say the biggest benefit for a data scientist working on this platform, rather than working on their own workstation and going to the businesses and grabbing sample sets of data to go see if a problem can be solved, on C3, if you're a Python user, great. I have my Python Jupyter Notebook. I connect it to my C3 environment, and I work off of all of the data in production. That's a big deal. That means no sampling error. That means when I build my model, I test it, I train it, and I go back to the business with the results of that model, the precision and the recall. I'm highly confident in what that means to the business user. That's one big benefit. Number two, if everyone likes this model and we want to put it into production, guess what? It's already an API. Any application can call it. right off of the platform. It doesn't need to be recoded into Java. Nobody has to scratch their head and say, how do we get it off of this data scientist workstation into a production context? I just upsert it as a type and I'm done. So huge benefit there. And a bunch of tools. We can go into tools later, but there's a lot there to allow business analysts to explore data, interrogate data, evaluate data loads, all of the feature functions for an application developer around how I do my work, how I push my work back into a main code branch, all of that stuff is there. We support a IDE Eclipse plugin, Jupyter Notebook RStudio, Digits. If you want to use text editor or browser command line interface, you can do that. Data visualization. People tend to get hung up on this and hyper-focused on the visualization. This is actually the easy part. And I say that a little bit tongue-in-cheek because it's still a challenge. But we can basically allow the data, the analytics, the output of the machine learning models to be pushed to anything. Here's a bunch of examples. I had one customer who was using SAP's Hybris system for their dealers who are not really a part of their business. They're independent third parties. And they wanted Hybris, that the dealers were already used to using, to call C3, get the results of a very complicated machine learning algorithm, and bring that back to Hybris without really having to change the UI very much of Hybris. Fine, it's an API. Hybris gets access and authentication rights, makes the call, brings it back to the UI, but the underlying data, the analytics was all C3. The UI just happened to be something else. So we support open source like React Angular, Tableau, Spotfire, QuickSight, Power BI, what have you, a whole bunch of these. So what does it take to build the most simple AI IoT application? How many of you ever wrote the program Hello World? Probably the most simple program you could write, okay? Our version of that is predictive maintenance for smart light bulbs. This is our version of Hello World. Very simple application. I would call it a degenerate application. You have a bunch of light bulbs, they have lumens, they have heat, they have on and off states that can be sensed. Pretty basic, right? So what would it take to build this on the C3 platform? This is what we provide our students who go through training. Like I mentioned earlier, we are teaching the companies that we support how to do development on this platform so they can solve business problems very, very quickly. They send their developers to C3 training. We have online Coursera courses. They can come to California for more advanced training. And this is part of that training, is building this application. So we've had hundreds of students take this, and we've kind of been monitoring what it actually takes to build this app. Before we did this, we actually wrote a 16-page product application specification of what this application is. And we built it ourselves, so we knew if we could use it for training, right? We wanted to perfect it. This was what they have to do. Build an application with the goal of achieving 80% precision and 70% recall. Gather the data and set up enterprise services to ingest 5 light bulb sources of data. Create a data model and load the telemetry use for 1 million light bulbs for 2 years with 15-minute frequency. This is not big data. This is manageable, right? Enrich the data and develop analytics. That is essentially creating, for you data scientists, you all know that's creating your features for your machine learning classifier. Most application developers have actually never done this, so we teach them how to do it. Create a predictive analytics AI model or a machine learning classifier to predict light bulb failure. And then develop 4 user interface screens to manage the data and view predictions. How hard could this be? All right, here's what they do. To set up the infrastructure, 0 hours. They get a URL and they start. Ingest model takes 1 hour. Data model takes 5 hours. The application or UI takes 20 hours. And the machine learning model takes 14 hours. This is about 5-person days. The fastest we've ever seen anybody do this is 2.5 days. And it was actually someone we hired from Minneapolis who was amazing. He just rocked this. So 5-person days for this. This is kind of what that looks like over a 5-day period. Sign up for their account, develop the light bulb data model on the first day, load the data on the second day, develop and test the light bulb, analytics on the third day, build the UI, test the performance, security, and reliability. This would cost most companies with that resource about $2,000 to develop this app on the C3 platform. This is what the application looks like. You basically have a summary indicator at the top with a risk distribution. They show that risk distribution in a histogram. What are the risk scores for each light bulb over time? Show that risk geospatially, so as they bring these data in, there's lat long, and part of the platform service automatically goes out and gets the geospatial location for every light bulb automatically. The developer doesn't have to do anything to take advantage of that. It's already there. What is the detail for each light bulb? So prioritize these by risk of failure, what's going to fail and when. And allow me to drill into any light bulb and see that risk score climbing and understand the reasons why. So it's basically taking the output or the results of the machine learning and turning it into something that a user or a human can look at and understand what's going on. This gets down into the actual measurement series or the time series data for each light bulb, so I can actually see the data graphically and tabular. And this needs to run on an AWS infrastructure. How many hours did they spend doing that? Anybody remember? 0. They spent 0 hours doing that. Okay. Or you could do it yourself. And people always say, who is your competition? I would say it's this. It is an approach. Is it the most efficient approach? Is it the approach of the core competency of your business is the question I think you ask yourself. So this chart right here came from, we actually gave that 16-page product spec to 2 software integration companies that do nothing but AWS services for companies. That's all they do. They're much bigger than C3, and this is their core competency. This was the architecture from that 16-page product spec that they put together. And one thing you'll notice over here, down at the bottom, was there was a bunch of stuff that they said, well, we would come back to that later after we built the app. Encryption, authentication, scheduling, monitoring, authentication, profiling, logging, auto-scaling. So those were not included. This was their effort to build this application. 5 people, 375 person days, nearly $600,000. Okay? The estimated amount of code that they believe they'd have to write to put those Legos together, to integrate the data, to develop the analytics, to develop the machine learning model, to build the UI and test it, about 12,700 lines of code. Our students are roughly in the neighborhood of about 600 to 650 lines of code when they're done with the application in a week. So the takeaway from this is that C3 is not an open source or cloud microservices experiment. We're not a data visualization tool, or I should say we are not just a data visualization tool. We support data visualization. We're not a closed black box environment, and we are not a replacement for installed enterprise systems. You can think of us as a system of systems. What makes sense to go in there is really driven by conversations with you. And we're fully comfortable saying we're not everything to everybody, but we are a lot of things. And this is just a select set of customers, but these are big companies. One of the most recent ones that was announced was Abnett and Royal Dutch Shell. And when you listen to what these companies are doing, these are very, very progressive companies. They weren't sitting around waiting for C3 to show up. They've got very large, efficient set of data scientists. They have application development teams. But what they didn't have was a consistent way to do things. And so one of the key themes that we've seen as part of this digital transformation happening in these companies is a creation of a center of developers who can help these business units go solve these problems very, very quickly. What is the goal? to ensure that these developers and data scientists never have any downtime, that they're always working on an application to unlock some kind of economic benefit to the business. They're not tinkering with toys, they're not playing around, they're solving real problems. And they're doing it very, very fast. I was at 3M at their last executive briefing a couple weeks ago, and one of the teams that got up showed an application which is sourcing price optimization. It's actually an AI algorithm app that is looking at every part and every material that they buy and providing an optimal range that they can use to go negotiate with their suppliers. Guess how many weeks they built that application in? It's a company with 90,000 product SKUs. 4 weeks. It was amazing to see that. The development team got up and did the demo for their executives. It was very impressive. So with that, I'm going to stop. We've got about a half hour left, and I'm going to turn the time over to to Julian from NG, and he's going to talk about how they're using the C3 platform. He'll give you the real-world story, not the marketing pitch I just gave you, but we'll leave a little bit of time at the end for questions. And if we don't get through all of them, Julian and myself and John Vignoki, who's in the back, will be right outside the door to take other questions as well. Thank you.
Thank you, Jim. Okay. So my name is Julien. I'm from NG, so does anyone know NG? No? No one? Okay. So NG is one of the biggest utility company in the world. It's a French one. You can recognize my French accent, probably. So we have like 65 billion annual revenue. It's 150,000 employees, and we are the first power producer in the world. Okay, and we are representing in 7 different countries, and we are in the US. So we have a business unit in the US. So we are divided in business units. We have 24 business units. And then we have like, I don't know, but maybe 1,000 or 2,000 subsidiaries all over the world. So it's really huge. So we will talk about like real application. So with Jim, we had the theory of C3. And now we will start with real applications. Just to give you an update on the digitalization within NG. So our CEO, so it's a woman. Her name is Isabelle Cocher. So she started, I think, 5 years ago to be the CEO of our group. And the idea was the 3D idea. So it's digitalization, first D. The second D is decarbonation. So it's going about like renewable and to get rid of all the thermal and nuclear plants. And also decentralized, because as you may know, everyone could be like an electricity producer. You can have your own PV on your rooftop, and so you can sell and you can buy electricity. You could do that. So we started first to check how many POC we had around like NG, around data acquisition, data science stuff, etc. And one more than like 300 POC. So POC doesn't mean it's in production. It's really like maybe some data scientist is running some R studio algorithm on his laptop, and it doesn't share anything. Then we started to appoint a chief digital officer. So his name is Yves Le Gélard. And the same year, in 2016, we started to create NG Digital. So NG Digital is the subsidiary I helped the creation for. So I'm leading the analytics and machine learning team and the COE, where we have like NG engineers, such as like software engineers, data engineers, data scientists. And it's in collaboration with C3 engineers. So we have like a team of, let's say, 20, 30 people. And now we launched the first product, real product, last year. Why we choose C3? That's the first question. So as you may know, so we had a lot of POC. We tried also to make our own analytics engine on top of AWS. We tried some other companies. We did our we had an in-house cloud platform, but we gave up. We spent a lot of dollars about that. And we had to choose something to help us speed the business. NG is not a tech company, it's a utility company, so you have to understand that. The DNA is not like really the software. We have a lot of data scientists, that's a fact. We have a lot of business analysts, but software engineering is not our strength. So we chose this platform because it can address like different kind of product. I will show you later. So this is the composition of the team. So we have roughly like 25 people now. And the idea was really like to speed up the business and to find a way to deploy like quickly application in production. You have to imagine that we have a lot of different businesses. We have B2C, we have B2B market, we are operating power plants such as wind turbines, hydro turbines, thermal plants still, gas turbines all over the world. So we have a lot of different problems here. So you have the B2C market where you for instance, you want to decrease the churn of a consumer. You have the wind turbines, you want to do maybe like predictive maintenance. You could have a power plant where you want to increase the coefficient of performance of these assets in order to increase the production with a lower cost. So we deploy now 3 applications like every 6 months with those resources. And we try to stick with a limited number of resources because if you have a lot of resources, you're not more efficient. That's my point. So now, after like 2 years of the collaboration, we have overall on the platform, let's say, 5 million different endpoints. And endpoints is not just a sensor. It could be like any kind of data type. It could be like a bill. It could be SAP document. We have 1 million sensors. So these are like real sensors such as Sigfox devices, LoRa devices, BMS, etc. And we have 17 million measurements a day. And now, in the platform, throughout the year, we have like 25 terawatt hours. So it's huge. So it's the consumption of the Republic of Ireland. So it starts to be something, I guess. So we're happy with that. So now I will show you some sample of what we're doing. So I think we have 3 different case studies. So the first one is Darwin, so which is around like renewable assets. So this is our digital platform for wind, solar, and hydro all over the world. So we have solar and wind turbines in the US. Don't ask me where exactly because I don't remember. So the idea was to do a project around data science because there is already a platform which is doing the data acquisition. So we do have a BMS on site which are getting the data from the wind turbines. So you can imagine that you have like digital sensors on your turbines. And we started the project for a 12-week period. And now we're able like we currently have, I think, 356 wind turbines connected for the moment. The goal is to have like more than 2,000 wind turbines covered. And we had applied some machine learning algorithm, which are ice detection. So for the northern part of Europe, you need to stop your wind turbine if there is some ice for a security reason. We are doing also like predictive maintenance. So you have the main bearing system. So if you have a higher temperature of what is expected to be, then also you have to do maintenance on the wind turbines. So we're using some, to be more technical, we did use some classifier and some classic ML algorithms such as boosted tree. And we have increased our performance of 2-3%. So the economic value is a forecast. This is not yet what we are gaining, but from what we're seeing on the 300 plants, this is what we can expect. The other one also is an algorithm we have. So we have 3 algorithms. It's underperformance. So which means that if your wind turbine is underperforming, then you have an issue. Okay, so this is the forecast we want to achieve. So we want to connect all the wind turbines we have. We will also connect all the photovoltaic, the PV panel we have all over the world, and we also have, like in Europe mostly, 10 hydro plants. So it will become to be a big numbers around that. So this is what we have used of the C3 platform. So on the left side, you have the data ingestion, just as the metadata of the wind turbine. So it's basically which wind turbine is it? It's the statical theorem data. You have the measurement. So this is the time series Jim was talking about. And then you have some user feedback, the weather, and some events given by the operation team. On the right side, you have the dashboard of the application, where you can monitor in real time your wind turbines. So you have to understand this is very important for everyone, and especially in our world now, to be like more proactive. So we know are in the first loop where we're getting all the data. We are trying to provide some algorithm. And then in the second part, we will try also to give like automatical feedback and to do like automatic stuff direct on the plants. So now we are not able to do that for security reason, because if there is some hacking people, some people hacking the system, they could do like bad things with the wind turbine. So we need like more accurate protection for that. The second use case is about district heating and cooling. So we have a steam production plant, which are producing steam for district heating and cooling system. And the idea is to optimize the process of the steam production. So we did a 24 weeks project. So which for a company as NG is very, it's very competitive because usually for us it takes like a year or 2 years to make products. So you have to understand that. Again, I'm saying that we are not an IT company, so we are very proud like to be able like to deliver a product in 24 weeks. In this case, the idea was really like to give a product to what we call an efficient plant manager. So the work is really like to optimize the way you will produce your steam by comparing like historical data and optimized periods compared to today's data. So here also we use the C3 platform. So this is the same. You have the sensors with the time series, and then you have all the asset metadata, which represent actually the plant. So on the right side, you have an overview, but it's more of the application. Let me show here. Okay, so it's in French, but so the idea is really like to find an optimized set of points of your performance of this steam generation, and really like to help to tune different kinds of parameters. So at the end, we have a lot of classifiers. So we are using, I think, like something like 300 features for the data scientist. It will help you. We have like 2 years of data at 15 minutes grain. So it's representing a lot of data. And the idea is to give like a really like a B2C end user style application. So it's not because you are giving an application to a professional that it has to be ugly and useless. So we really wanted to have like really something like easy to use and efficient and fast to use. Because even those people, they don't want to spend like an hour to wait for the end of the model calculation. So to do the calculation, take the models, and give the output, it takes like between 1 and 2 minutes. So we scale over like maybe 20 workers, to speak in AWS world. And in 2 minutes, you have the result of your scenarios, which is really fast for us. Because usually before, we had some data scientists doing the same work, and it took maybe 3-4 hours for each scenario. So when you have like per day, when you have to make and to do like 20 different scenarios, you can understand the efficiency you're gaining by using such tools. And this is the result. This is the outcome. And it gives you a sense of, okay, you can maybe there is a valve, so you have to turn off the valve by 20%, and then you will gain, I don't know, like 0.5% of production. So the other use case is Ohio State University. So maybe you know this university. So it's one I've heard. This is one of the biggest universities in the US, the Ohio State University. NG has won a contract to do the energy management of this university. So this university is like around like 400 buildings, including the Horseshoe, it's the Buckeyes Stadium. It's a long-term contract. It's a 50-year contract, and the idea is to build a smart grid on this university because they do produce some electricity already. They have a power plant. So the first step is to gather the consumption of every single building. So what we have done already is we are installing smart meters in every buildings to gather the data through a BMS system. So the BMS, maybe you may not know, but this is something where you can gather all the data and then extract those data to the cloud platform. I show you. So this project we have done in 16 weeks, not the installation of the smart meter, but like just the software part. So this is, and the idea is to save not 5%, but 10% of energy within 10 years. Show you some, so this is some screenshots we have done. So we have, in the contract, so we have a B2B part, and what we have done also, we are implementing a web application for the students. So it will be a public application, so anyone can go there to give you a sense of the consumption of every building, to compare the building to each other, to do like peer comparison, and to also have a sense of is your building efficient or not. So you can have like a ranking of your building. So this is the map of the university. So here in red, you will have like the over-consuming building, and in green, of course, the buildings that are really less consuming than it used to be. So behind the scene, we are gathering the data, of course, and with some other algorithm, we are checking how the building is behaving in terms of energy consumption. And once we have those figures, we can define some measurements we can take, like changing the bubbles or having a strong analysis of the building and what we need to do to help the building to be more efficient. Okay, The last one is about B2C market in France. So you might not know, but in France we are rolling out all the old meters, and every B2C user is becoming a smart user because Enedis, so this is the French electricity provider, is giving to everyone a smart meter to get the consumption automatically. And the rolling out is about, I think, 30 million meters. So it's a big project. And the same for gas. So here is some pictures of the smart meter. So we start the project, I think, 1.5 to 2 years ago, and we released the first product in 6 months. So we are acquiring 8 million data points a month. And we have 2.6 million, currently we have 2.1 million customers, 1.6 for electricity, I think, and 500,000 for gas. It's a complex, it seems really simple, but it's really complex because you have an old IT system, I'll show you, which is made basically of pricing data coming from SAP. And we have some other IT systems. So we have 10 different IT systems, very old, like old CSV file, SFTP system, all the databases, Oracle, Teradata, which are not able to be at scale. So it's complex because you're not like in a perfect AWS world. So we try to add a layer on top of that to help us doing the work before going to the C3 IoT world by having like an ETL layer which is really like custom made. We try to find some stuff from the market, but there was no fit. So we did something on our own. And what we're doing is we're giving, it's a small, but on the right side now you can have the consumption. So every end user can have its consumption per day, kilowatt per hour, and also all the details of the bill. So what's the price, the kilowatt hour, the tax, the state tax, etc. You also have a benchmark. So you can compare yourself with a similar home. So you can see if you are a good consumer or a bad electricity consumer. And so for the moment, the idea behind that is really like to help the churn. If I go back, so first there is an increase of, I think it's more than 11%. I think the latest figures are about like 20%. So now people are coming back to the web page to watch the electricity consumption, and also it helps dividing the churn by maybe also 20%. So it's very interesting tool. Okay, so I'm done. I hope it's not too boring. So thank you.